So thank you everyone for joining us today. My name is Rafael Botwell-Weiss, and I'm responsible for customer experience in App9. And today I want to talk to you about our new open source initiative called Mizu, the API traffic viewer for Kubernetes. A little bit of housekeeping when we start. First of all, this session is recorded, so you'll be getting this recording probably tomorrow with the presentation. Please feel free to ask any questions. There's the Q&A button at the bottom of the panel, and obviously just ask the questions. My colleague Noga will be looking at those questions, and we'll have a Q&A session at the end. Please follow us for more cool stuff and updates on App9. We previously had the Macintosh open source, and now it's Mizu, and who knows what will be next. So with that, let's start. Today's session is about Mizu. And before I talk about what is Mizu, let's talk about the problem. And as developers, we build software. So in order to do that, we need to create code, integrations, usually for a client or between two applications, two services. And in order to do that, we do a lot of coding, trying, fixing, till it gets done. Basically, there is I wish everything was as simple as IKEA table with all the instruction, but the reality is that we are constantly trying, making mistakes, fixing them. And in order to do that, we need to constantly debug and troubleshoot our work. I'm trying a new library, I'm trying a new pattern, and literally I'm just trying to do a new integration and see how it goes. So the tools that we're using, probably curl, Postman, directly from the code in order to initiate a request and to view them. You know, if we're front-end developers, we're good to go. We have the dev tools, right? We have Fiddler. When the going gets tough, we have TCP dump, Wireshark, Charles proxy, if you know about it. When we look at the actual TCP UDP level, and everything was really good. It was fine. We've done that for over 20 years, basically, until we got the microservices in place. And what happened, basically? In the last couple of years, all the cloud native and everything kind of moved to the cloud, and then we decided to go into microservices. We talked about that in a different blog and webinar, but the idea is that today's applications are built from a lot of building blocks. Each block is a service. It can be 10 services, 20, hundreds, and thousands of services constructing the entire application or applications. Most of them are internal. Basically, Kubernetes can manage them. They're in a couple of namespaces or couple namespaces scattered. The only way to get to them is basically through the API gateway. So we were introduced to API gateway or the BFF, backend for frontend. We tend to say service, but behind it, it's more than just a service. That service is running, or let's say it's kind of allow me to get to a pod, and maybe there are 5 pods and 10 pods, 20 pods of the same service. So when I want to debug something, I want to see like which of the pods actually got the request and how it happened. And if it's a stateless, then maybe the first request got from pod number 1, and the second one got from pod number 3. I need to figure that out. And also we got a lot of new technologies. So for example, serverless calls. So that's great to have a Lambda somewhere, and now it generates code to requests to me. I'm not talking about stream events like Kafka, just general queues as active end queues, and etc. And life are not simple anymore. At least for us developers, now when we need to write integrations, we basically we are looking for a needle in a haystack. And it's also very uncomfortable because I need to do port forwarding and map all the internal services in the dev environment into a couple of ports on my end. And then if I have Postman, for example, teach Postman how to get there. So if we look at a simple example, and if you have following our webinars, you kind of feel right at home with the sock shop application. But if we look at it and I want to do something super simple, all I want to do is check a new front-end feature that involves catalog and cards. I can get to the front end easily, but those services and the rest of the services are internal inside my Kubernetes cluster. So in order to do that, I need to create some kind of a port forward or a proxy. Those tend to be kind of faulty. It's like nice to have solution, but it's not robust. God forbid if I want to run a performance test or just a test with a couple of requests, or basically it's a hard time. So how would I do that? If I want to track the sample, the requests in front end, going to catalog or going to cart, how would I do that normally? It's a lot of try and catch, fail, try that again, asking help from the DevOps. It was great if we will have an easy tool for that. And actually in App9, what we do is basically that. So we kind of thought about that, hey, maybe we'll use our tool to do that. So we started exploring that, and our observability is based on traffic. So maybe we'll just use our tool to kind of debug that, and the developers will be able to get that in real time. And if you join this webinar, you're probably interested in Kubernetes. So like you, we also built on Kubernetes, and we have exactly the same problems, either in our backend or when we install our solution in one of our customers. We need to see how it interacts with the different pods, etc. So we kind of tailored our tapping, and after a couple of iterations, a lot of iterations actually, it was kind of ready for the outside world, and we decided to release it as open source. So we called it Mizu. Actually, the Mizu is a noun, means water. So we found it kind of interesting that you'll be able to watch it just like you watch water down the river. And it allows you to just watch what your application are handling at the moment. It's your outbound requests, inbound requests, and maybe you want to kind of zoom in into 2 services or all of the services. It automatically supports both REST APIs and gRPC. And we're actually planning to add more based on the successfulness of this tool. It's super simple and lightweight, and I'm going to show you exactly how I'm going to demo it and use it for that. And the best thing about it is it doesn't require any code change or an application change. So for example, I don't need to include an SDK and teach all of my developers how to use that to change their code. And I certainly don't need to change the architecture of my application. It just tap into it and get me the traffic. And the most important, it's a really point tool. It's like it goes there, clean after itself, and done with it. Kind of dev tools for your Kubernetes. So basically how it works. The first thing is that Mizu, after you install it on your laptop, it connects to your Kubernetes cluster. And it's basically look at the same cluster that your kubectl is configured at the moment. And it asks itself, which of the pods do I need to tap to based on the regex that we defined? Let's say we have 3 pods, and then for each node that those pods are hosted on, it creates a daemon set to tap the traffic of these pods. So for example, if I have a cluster with 20 nodes and I only need to tap 3 nodes out of that, it will not tap only those 3 nodes. So it's kind of very lightweight and also very important not to crash the cluster while you're trying to debug something. The last thing it will do, it will generate a small pod that will be the kind of a collector for all those daemon sets, and will provide the GUI for that. So when you look at something and maybe your colleague wants to look at something, then they can just do Mizu view, and then together you look at the same traffic at the same time. Super easy, done. You just Control C, it deletes itself from the cluster, clean all the resources, and like never happened. How you install Mizu? Super simple. One, you just curl into this command and you give it access to run. Or if you like to just build it from the source, you can just git clone Mizu and just make the CLI yourself. Another thing that you want to do is kind of in our GitHub for every release, we have our hash. Just make sure that you have that hash and just follow that practice on security. And that's it. You're good to go. It's super easy. It's built with Go, so it's kind of a couple of megabytes. And here are a couple of common use cases to use that. So if I would like to tap a specific pod, I can just do Mizu tap and the pod name. You'll get that by doing kubectl get pods, and you'll see that pod. Another is like a more complicated one that I want to tap all the services that starts with CA, right? So cards, catalog, card, maybe no problem. I can just do that regular expression and be done with that. I want to tap to a specific namespace. So what I will do, I will just kind of say tap everything you see in the pod's text and then the namespace. And full-blown debugging, I want to see everything. Just keep that regex -a and capital A. You're good to go, and we will tap everything in the cluster. New pods, deleted pods, everything. We'll just tap, and you'll see the traffic. So I think the problem is clear. We understand what Mizu is. Let's see it in action. So for that, I prepared a small demo. I'm going to this is just to explain what we're trying to do. I will be a developer, and what I want to do is tap frontend, catalog, and cards. And as I said, frontend is exposed outside with the DNS. That's easy. This is my backend and my API gateway. But I want to see catalog and cards traffic. And what I want to do is, and they are behind, like they're inside my Kubernetes cluster, so I can't access them directly. Usually I'll do a port forward or something like that. I'll show you how I'm going to do that. Here I have the command line with Mizu already installed. And what you can see here is just the command line itself. Mizu tap. I want to have everything that starts with CA and, or in this case, or everything that starts with front. So with this, I'll get catalog, I'll get cards, and I will get front end, but I won't see all the rest of it. So let's do this in action. See this in action. We are starting to tap those pods, and it's in the namespace sock shop. I will explain this in a second. That's a super nice and cool feature that is about to be released. So you'll see that. Mizu tells me which pods I'm actually tapping to. So you can see here catalog, the database, cards, and the database and front end. And with a click of a button, I can just go here and look at the traffic that will be provided. So for that, let's start a new browser here. And I will just go into my cluster. Notice that I'm using the DNS record, right? So I'm behaving and testing just like a normal user. And automatically, I can see all the traffic here. So for every command that I'm actually going to do here, Mizu on the fly gathers everything. And you see, oh, I got 404 here. I can click on colorful, and I can see all the requests in real time, just like DevTools. But you can see here, on browser, it also tells me the actual service. So I was using the DNS record because I don't know which service it is, but it tells me, teaches me what happened in my Kubernetes cluster. And for that, every request here, I can actually go see that it's the front end. I can see the request. I can see the response of that. So let's try and get something that has a little bit more depth to it. Here we go. That's the request with all the headers. And this is the response that we got from the server. Here just tells me all the pods that I need. The beauty of it is that now I know that this came from my API gateway and it's cataloged. So let's look at the same catalog, same request that was actually processed by the service catalog. And if we click here, we can see the request and we can see the response here, which was behind the API gateway. So now, if I would like to kind of maybe do that again, I can open Postman, for example. Let's see, here's my Postman. Here we go. And I can generate that same request again and see what happened here. And I can start tailoring with play with that all from the front end. Of course, I can't do that directly there. I need something that lives in my Kubernetes cluster for that. But super simple to debug and understand what I'm doing, what my application think of like a mobile service. I can just, record, do something in my mobile device, and then see how it affects my backend services. Super cool, that's nice, but let's see something even nicer than that. What we have is a small file called enforce policy. An enforce policy, let's just tweak that a little bit. Enforce policy allows me to define a set of rules for Mizu to validate. So let's go for that for a quick tour here. A name for a policy, only in property, and I want to make sure that if there is a JSON with a name there, the value I want to validate will be holy. And the same thing here, if I have some kind of a latency on catalog and only on service catalog, I want to make sure it's less than 10 milliseconds. And I can define a lot of rules on that. So for example, here, I want to make sure that there is a price and it's only digital. It can have dots, it can have without dots, but I want to make sure it doesn't have any alphabet or special characters. Validate content length, for example. And if you look here on the rules, then we can actually see that a validation error. Let me just run this again. And this time I will save the file here. I just did Control C. It removed all the resources from my cluster. Let's run that again. Here we go. And again, do something in my application, go to catalog, and we can see all the traffic here. So for every request, Mizu look at the rules and validate it. So in this case, it's just the latency less than 10 seconds, and we can see it was 4 milliseconds, and here it's less than 10. It's obviously less than 10 milliseconds. I can go to something in cards, look at the rules. Not this card, I guess. Here, and no rules applied. And obviously, I will not apply something for like pictures, something like that, all the CSSs. Let's see here, and let's break the rules. Like the rules. So what I would like to know, I would like to verify that wholly, there will be wholly 1, 2, 3, 4. And I want to make sure all the requests are within 2 milliseconds. Okay, so for that, I'll just stop Mizu. And it removes everything. And I will apply the new rules for that. And I'll generate a little bit of traffic here. Here we go. And, oh, yeah, I should have done it the other way around. That's what happens. Sometimes it's live demo. I need to, okay, that's great. That's the beauty of it. Let's just kill it. Here we go. We'll get pods in default. No resources. Now let's run Mizu again. Here we go. Here's Mizu, and let's generate a little bit of traffic. Go. Here we go. And this one, we have 4 rules applied. One failed because the name in this request did not match whole 1, 2, 3, 4 Y. And obviously, that's the validation that we did, where we can see that we do have a name and it was colorful, right? So that's the first thing. The second thing is that it failed due to latency. It was actually 2 milliseconds, but requested less than 2 milliseconds. So we got another fail. Think about that when you have a troubleshoot, you have to troubleshoot something, or you just develop new features and you have those set of rules, things that you already captured in the past and you don't want to kind of have them the second time. You have those defined rules. You just spin up Mizu, get your code, and then you can see either a schema validation happened, a schema violation happened, or a performance issue happened there. Maybe instead of latency, you can put like 90th percentile, something like that. Those things are super powerful, especially on the microservices level, because the amount of changes that are being applied to those applications and their services is not once a week, it's every day, continuously being updated. And this is a tool for developers to, one, troubleshoot faster in an easier way, not through the gateway with Selenium or something like that, or with Postman through the gateway, directly into the services themselves. And again, dev tools for Kubernetes services. Let's see, we have 5 more minutes. So a couple of more information. Mizu website, getmizu.io. You'll find it quite quickly, and it explains everything that you need, how to download it. You have that here, and how to basically the download is also the install and how to use it. The repo, and we have Mizu Slack in our Up9 community stack, so you can just try that and go to open source Mizu, and you'll find that. Feel free to contact me, either email, Twitter, LinkedIn, if you have any questions, thoughts, feature requests, bugs, either through me or in GitHub directly. We would love your feedback. Let's see if we have, Noga, do we have any questions for the audience?
So Rafael, first of all, thank you so much. It was fascinating. It's always nice to see the open source tools that Up9 contributes to the community. If anyone has any questions, like Rafael said at the beginning, you can click on the Q&A button at the bottom of the panel and just ask us anything. Okay, I see we have a few questions. So the first one is, which protocols does Mizu support?
Cool. So Mizu supports REST API, and it supports gRPC. As of today, we are looking to add more. We're kind of thinking Kafka, other queues, maybe Redis, and also, TLS, for example, C encrypted. We would love to hear your feedback. What is the one that hurts you the most? So feel free to reach out.
Yes, so it's good that you mentioned the feedback. We're always happy to get feedback about our tools. So you just like email Rafael or reach out to us on LinkedIn, and we're happy to hear what you have to say. We have one more question. If you could please explain how traffic validation works.
Sure, no problem. Again, you can create any YAML file in this structure, and what you see here is basically a set of rules. Every rule you can give a name to it, and then you can define what type will be text, HTML, and JSON. What to validate on that. For example, here it's on latency. Then you provide what to validate on. In this case, it will be a JSON path extractor because the type is JSON. In this case, it will be latency. So we'll just measure the latency for that and the value for that. In this case, it will be what will be the value of that key. And this is actually the validation that happens. Can be a value or a regular expression. Perfect.
Thank you. Okay, if there aren't any more questions, then I don't see any more. Okay, so Rafael, thank you again. Thank you everyone for joining us. The recording will be sent out tomorrow. We wish you a good day or good evening wherever you are in the world. And we hope to see you next time.
Thank you very much, Noga, and thank you everyone for joining in.